Hey grade 12s and welcome to this video. In this video, we're going to be working on Gauteng's Mathematics Paper 1, the 2022 Pretrial. So this paper is for 3 hours and it is for 150 marks. So let's go on to the first question in this. So question 1, let's go ahead and work through this. So in question 1, we are given in 1.1.1, we are given this equation and we need to solve for x. Okay, so with this question, something that you should always notice when they give you an equation, you should always check if one hand side is equal to 0. And as we can see here, the right hand side is equal to 0. So this is what we're going to do. Remember, what we have is that 2x being multiplied by x squared minus 1 is equal to 0. So if you have two things being multiplied by each other and they give you 0, it just means that either one of them must have been equal to 0. So it could be the case that 2x was actually, the final value was 0. So it's like 0 being multiplied by that. And that would, of course, give you 0 because anything times 0 stays 0. Or it could be the case that 2x was just 2x being multiplied by that being 0. And so you would have gotten a 0. And that's why we're going to go ahead and say that it's either that 2x is equal to 0 or that x squared minus 1 is equal to 0. So the one thing here is just make sure that one hand side was equal to 0. Okay, so in this case, solving for x, we'll just go on to dividing the both sides of the equation by 2, and so therefore x would be equal to 0. And here what we have is x squared minus 1. Now you can view this as difference of two squares, or you could also just do this. So let's leave the x squared on this side and we're going to take the negative 1 over. So we have x squared is now equal to positive 1. Then we need to solve for x. So we need to get rid of this squared. So we're going to square root both sides of the equation. But the thing that you need to remember with square rooting both sides of the equation is that you need to include a plus and a minus here. So x is going to be equal to positive or negative 1. And just to remember, the reason we add the plus and minus is because this is an equation and it had that x squared was equal to 1. So when we have x squared, the degree of the equation basically tells you how many possible solutions you have for this equation. So in this, we cannot just say 1 is the answer because yes, if you say 1 squared, you do get 1. But if you say negative 1 squared, you also get 1. So you have to include both. So these are our solutions. In this case, clearly we have three solutions. It's either x is equal to 0 or x is equal to 1 or x is equal to negative 1. And then moving on to the next question. Next question is 1.1.2 and we have this, we need to solve for x. And they already tell you correct to two decimal places. And you can see it's for 4 marks. So this is a case where you have to use the quadratic formula. Okay, so with this question, the key to really solving equations is to really focus on the goal of the equation. The goal of all these equations is to solve for x. So we need to get x to be on its own. We need to find a way to solve for x. So looking at the way this equation is right now, they do also give you the restriction that x is not equal to 0, of course, because this x is on the denominator. And if it was equal to 0, it would make this undefined. Okay, so how you have to solve for x here is think about the fact that you want to solve for x. Right now, what is stopping you from solving for x? What looks like a problem right now? So this looks okay, that looks okay. The problem is this. Because x is on the denominator, it's kind of stopping us from solving for x. So what you can do is ask yourself, how do you get rid of an x on the denominator? Or you could actually phrase this question as, how do I get rid of this if the 2 is being divided by the x? So the x is the problem and the x is here because the 2 is being divided by the x. The only way you can get rid of this is to do the opposite of it. Instead, multiply by x, since we can see that the 2 is being divided by x. But because this is an equation, what you do on the one side, you have to do on the other side. So what we can say over here is we can go ahead and say we're going to multiply this hand side by x, and we're also going to multiply that by x. And then this is what happens. We have one term here being multiplied by 3 terms, so it's going to FOIL in. X times x, that's going to give you an x squared. And then we have the x times the negative 6, which is a negative 6x. And then, of course, we have the x times this, okay, 2 over x. And so this is what happens. You have your x being multiplied by the 2 over x. So that we just have two fractions, I'm going to put this x over 1 because every whole number or variable is actually being put over 1 if you want to put it as a fraction. So if you look at the way this is, look diagonally. Since we are multiplying, we are able to cancel x like that diagonally. So another way we could have done this is by saying the x multiplied by the 2, and that would have given you a 2x, and then the 1 multiplied by x, which would have given you an x. And so you see that x is common and it would cancel, and that's how you'll be left with 2. So you can go ahead and cancel it out like that and see that, okay, you just have a 2 here over 1, so it's just 2 as well. Okay, so that gives you a positive 2 is equal to 0. So now you see that we have a trinomial, and because they said correct to 2 decimal places, we have to use the quadratic formula. So here's the quadratic formula, and then we're just going to go ahead and substitute our a, our b, and our c. So our a is clearly 1 because that's an invisible 1 in front of the x squared. Our b is the negative 6, and our c is the positive 2. And then let's see what we get. So on the calculator we get this, but remember you just have to round off to 2 decimal places because that's the instruction that they give you on that instruction page. So we can go ahead and say that x is equal to, I'm going to take the decimal form, so 0,35, and as you can see the 4 is going to round down, so it just stays 35. So 0,35, and this is when I put the minus. I always start with a minus because it's a smaller value. And then, or if we change that to a plus, so then x would be equal to 5.645, but that would round off to 65. So 5,65. And that's our answer for that one. Okay, and then next we have 1.1.3. We have these two binomials being multiplied by each other, and it's greater or equal to 6. Okay, so with this question, remember that you can only start taking these brackets and equating it to the number here if the number over here is 0. Sorry about that. If the number over here is 0. But in this case, this number is 6. So you cannot do that. So what we have to do is multiply these out and then take the 6 over. So we're just going to say the x multiplied by x, which is going to give us x squared, and then the x multiplied by positive 4, which is positive 4x, then negative 1 times x, which is negative x, and negative 1 times 4, which is negative 4. And then we're taking this positive 6 over to the left hand side, and that's going to become a negative 6 is now greater or equal to, nothing is here now, so it's 0. Then let's just go ahead and simplify this. We have x squared, then the 4x minus x is going to give you a positive 3x, then negative 4 minus 6 is negative 10 is greater or equal to 0. Now here comes the part where you have to factorize, but the truth about this is that you don't really need to know how to factorize in order to still get your full marks here. And one of the reasons that will help you more is because you just have an x squared here. You don't have a 2x squared or 3x squared. You don't have a coefficient in front of x squared. So first I'll start with the method where you have to factorize. So if you wanted to factorize this, just open up 2 brackets, and we're still saying greater or equal to 0. Then since we have x squared, we're going to say x and x. And now here, since we have negative 10 as our last term, we're going to think of 2 numbers that when you multiply them, they will give you negative 10, but they will be able to also give you a positive 3 in the middle. So factors of 10, that can be 2 multiplied by 5, right? But then, or one of them has to be negative basically. But how can we write them so that when we add them together, they can give us a positive 3 in the middle? So you could have said 5 minus 2. So positive 5 and negative 2. So that's one way you could have factorized it. And so we're going to lay down our critical values. It would just be the x, and we're seeing this as if you had to take x plus 5 and make it equal to 0 just to find the critical value. You would have taken the 5 over and gotten a negative 5. So you don't have to include this step. Then we're saying, or we have x and we're going to take the negative 2 over and get a positive 2. Okay, so this would be a case that you did factorize. Even if you didn't know how to factorize trinomials, you could still get your full marks here. So this is what you could have done. You could have used the quadratic formula. So with a pencil, just don't show them, because if you show them, then it's kind of like you are already telling them I didn't factorize. So you can actually just put the quadratic formula on the calculator instead and put in your values for A, B, and C. So like this, for example. So I put in all the values in the quadratic formula and you see that I get an answer of negative 5. That's your answer over here when you're laying down your critical values. So that's what we get over here, right? So that's what we get over here. Now, how to just put it back as a factor, you just open up a bracket and say x, and if when you found the answer it gave you a negative 5, then as a factor it must have been a plus 5. Likewise with this one, if I change that to a plus, you're going to see I get a positive 2. So I know my critical value is x and positive 2. So it means that as a factor, it must be x minus 2. So that's just something you could have done if you didn't want to factorize. But I do think it's quicker to factorize than to use the quadratic formula though. Okay, so now that we have our critical values, we have to now solve for these inequalities. So in grade 12, they don't really expect you to use the grade 11 method of solving for inequalities. The grade 11 method is where we draw that number line and then we put in our critical values down. But in the grade 12 method, they don't really, if you look at the marking allocations in grade 12 or the marking guidelines in grade 12, you will notice that they do not really give you that whole number line. It's because they don't really expect you to work it through like that. They expect you to work this through as if it is a graph, because it is. So this forms a parabola, and the parabola is saying x squared, the equation of it is x squared plus 3x minus 10. So first you have to ask yourself, what kind of parabola is this? Is it smiling or is it upside down? Okay, because x squared, the coefficient is 1, it's positive, so your parabola would look like this, right? So it is an concave up parabola. And we don't even need the y-axis, we just need the x-axis. So we have our x-axis over here, and now the x-intercepts that we have are literally these values here. So we have the negative 5, and over here we have the 2. Now remember that this inequality says greater or equal to 0. So you need to first of all check. When you substitute negative 5 back into this equation, does it give us a value equal to 0? And we can go ahead and check that. And you can see it does give you a value equal to 0. And this is something that you don't have to actually check. Because if it is a parabola and these are your factors, then this is a factor of this equation. Of course, if you substitute it, it will give you 0. Okay, so we know it gives us 0. So we can go ahead and put a line under it for equal to. Likewise with the 2, if you try it, it will also give you 0. So put a line under it for the equal to 0. Now we just have to find out which direction it goes. And this is the easy part. In this part, all you have to do is focus on what the inequality is saying. It's saying it needs to be greater than 0. We've already dealt with the equal to 0. But this parabola, we're looking for the places where the parabola is greater than 0. And this is where the graph comes in. So this greater than 0 is speaking about a y value. So the y values, we want to know on this graph, where are the y values of this graph greater than 0? The y values are on your y-axis. You never really draw a y-axis. I'm just doing it so that I can explain this part. So this is your y-axis. The y-axis is divided into two parts. A part that is smaller than 0 and a part that is greater than 0. And all we are doing is finding on the graph, where does the graph have y values that are greater than 0? So all we have to do is actually find the parts of the graph that are greater than 0. So let's look throughout this graph. So over here, look at this part of the graph. Does this part of the graph have y values that are greater than 0? So definitely not, because if you look at this like a point on here and you look for its y value, that's a y value that is smaller than 0. But if you went to the upward parts of the graph, I always start from the left. So here, you see this one, the y value is greater than 0. Here it also have a y value that is greater than 0, y value greater than 0. Now we have to answer them in terms of x. So we are saying, what are the x values that belong to these parts of the graph that have y values greater than 0? And if you map it down, so I'm going to map it down, I had this point, map it down to here. If I map that down to here and I map that down to there, I'm looking at what are these x values compared to -5, since -5 is your x-intercept. So these values, if -5 is over here and these values are here, these are values that are smaller than -5. They are moving towards that direction, towards the left. Okay, so that's how we answer the -5 part. These are y values that are smaller than -5. And then we're going to do the same for the 2. So if we look at the graph again, and we're looking for y values greater than 0. So here, all through here, you see these are y values smaller than 0. So we cannot take any of these parts of the graph. But the minute we reach here, you can see here, these y values, they have y values greater than 0. So since these have y values greater than 0, you have to tell them what the x values of these parts of the graphs are. So if I have this point over here with a y value greater than 0, what is the x value compared to 2? Again here, what is this x value compared to 2? And you can see now that these values are going this way. These are values that are greater than 2. So we can go ahead and answer them. X is greater than 2. Okay, now the last thing to just do is just check if your values are related. Is there a relation between your values? And in this case, no, there is no relation because the values are facing in completely opposite directions. This one is facing that way, that one is facing that way. They are not pointing towards each other. And so this is just your final answer. You do not need to write it as one inequality. So that's 1.1.3. Okay, and then moving on to 1.1.4, as you can see, we have a surd. Okay, so this is an equation with surds in it. Now, in this equation, you notice there's something different about this equation with surds. Notice that you have the square root of x minus 2, and on the denominator, you also have the square root of x minus 2. And when you see this, we have to use a method called the K method substitution. So when you see something being repeated in your equation, we're going to take that thing and make it equal to K. So we're going to say, let the square root of x minus 2 be equal to K. So wherever we see square root of x minus 2, we're going to replace it with K, just so that it will be easier to solve for this equation. So I see the square root of x minus 2, I replace it with K. So we're just going to have K. And then after that, we have a plus 3. So plus 3 is equal to 10 over square root of x minus 2. We replace it with K. So this is the equation we have. And first, before we solve for x, we need to solve for K. Now, solving for K in this equation, just like the one that we had, it wasn't here, it was in this one, so over here, right, where we have that variable that we want to solve for in the denominator. Since K is on the denominator, we're going to have to multiply both sides by K to get rid of that K on the denominator, because that is stopping us from solving for K. So it's an equation. What you do on the one side, you also do on the other side. So now we're going to have, when we multiply those, that's going to be K squared, and then multiplied by 3 would give you a positive 3K is equal to, and so here, remember this is K over 1, and the K's would cancel diagonally because we're multiplied. Then we have 10 over here. Now we can go ahead and take the 10 over, so we have K squared plus 3K minus 10 is equal to 0. And this looks very familiar, so it seems to be the same factors as the one in 1.1.2. And so here we just have to factorize. So you can use the quadratic formula, or you could also just manually factorize it. So we're going to go ahead and open up two brackets, set it equal to 0. We have k and k. Then we need factors of negative 10 that can give us 3, and that will be positive 5 and negative 2. So therefore it means that k is either equal to negative 5 or k is equal to positive 2. Okay, and now we solve for k. Okay, but remember in this equation, we actually have to solve for x, not just k. So k was just to help us. The main goal is to solve for x. So remember in the beginning, we let k to be equal to this. So we're just going to replace this back here now, since that was k. So we're saying now that the square root of x minus 2 is equal to negative 5, or again, k is this, so the square root of x minus 2 is equal to 2. Okay. Now with this question, if you see that the square root of something is equal to a negative number, that already looks weird. That should never happen. If you square root anything, so if I square root 4, it gives me a positive 2, right? If you square root, even if this x was like a really big number, even if it was 100 minus 2, you're still going to get a positive number. So there's no way you can square root something and then you get a negative answer. But don't worry, you didn't even need to know this to be able to get the answer right. So from here already, I would have already cancelled this out. But I will actually just take it further just to show that even if you didn't cancel it out from here, you'd still be able to find the answer. So from here, x already has no solution. There's no way these two are equal. The square root of something can never be negative. But I can also just take it further and show you why it's not going to work. Let's say we were just still working this out. So in order to get rid of the square root, we would square both sides. And when you square both sides, this square root now cancels with the square because they are the inverse of each other. So we now have the x minus 2 is equal to, that will give you 25. And so x is equal to 25, and then that becomes a positive 2. So 25 plus 2 is 27. Okay, so here the answer we're getting is that x is equal to 27. Okay, or here, again, we also want to get rid of the square root, so we will square both sides, and we'll have that x minus 2 is equal to 4. Okay, x is equal to 4, and that comes over, becomes a plus 2, so x is equal to 6. This is how you would have found out that this one was not going to work. And this is something that you should always do when you have surds. Always check that your answer is correct. So we're going to try the x is equal to 27. And substitute that back into the original equation as it is. So if we are substituting, this is the original equation, x was supposed to be here. But since x is equal to 27 for here, let's try and see if it's true. So if you replace 27 here and 27 here, here this is saying 27 minus 2, but the square root of that, 27 minus 2 is 25. The square root of 25 is 5. So this is 5 plus 3, which is 8, okay? And we're saying that it's equal to 10 over, again, 27 minus 2 is 25. Square root of 25 is 5. So that's 10 divided by 5, which is 2. You see, 8 is not equal to 2. And that's how we know that x is not equal to 27. So even if you didn't see that that was not possible over here, if you checked if both solutions were correct, then you would have found out that that's not true. You get an extra mark for checking which one is valid and which one is invalid. And then we can also just go ahead and check the 6. Okay, so here instead of the 27, now we have the x is equal to 6. So if you had 6 minus 2, that's 4. The square root of 4 is 2. 2 plus 3 is 5. And this is supposed to be equal to 10 over the square root of 6 minus 2. 6 minus 2 again is 4. Square root of 4 is 2. So that's 10 divided by 2, which is 5. So even if you had put this on the calculator, you see 5 is equal to 5. The equation balances out. The left is equal to the right. And so therefore, that means that x is equal to 6 only. Okay, so you have to actually show them that you're invalidating this one, and here you're saying that this one is your solution. You get an extra mark for that. Okay, moving on to the next question. Okay, so our next question is in 1.2. Solve for x and y, so simultaneous equations. So with simultaneous equations, they're quite simple. All you have to do is identify the linear equation and identify the other one. So here we have two equations. All you have to do is identify the one that is the linear one, and we're going to call that equation 1. So this is linear, so we're going to call this the equation 1. And this one is the second one, so we'll just call that equation 2. So we're going to take equation 1 and form a new equation, equation 3. So we have x minus 2y is equal to 1. And just look for which letter can easily be made a subject. It would be x in this case because it doesn't have a coefficient. So x is equal to, taking the negative 2y over, it becomes a positive 2y. And the 1 is still positive. So now this is your equation 3. Then you have to substitute this equation 3 into equation 2. So wherever you see x, you're going to replace it with 2y plus 1. So we have 2x squared. So we're going to have 2, open a bracket and say 2y plus 1 all squared. Then minus xy. Now in this one, it's best to just write it like this. Since the x is first, just write it as minus y, and then in brackets, put what your x is supposed to be. So minus y, and then in brackets, the x is now 2y plus 1 because that's our equation for x. So 2y plus 1. And then continue, we have minus 5y that doesn't have an x. So minus 5y, then minus 3y squared minus 2 is equal to 0. So here, just be careful as you're working with this. Try not to make any mistakes. So here we have 2. Now, in this bracket, the reason why it is best to use shortcuts and just use methods that are quicker to simplify is so that you can avoid making mistakes. So I'm going to show you how to simplify a trinomial, or really a binomial that's been squared. If you ever have something like this, x plus 2 all squared, all you have to do is first square the first one, which is going to now be x squared. And then, so instead of rewriting it as x plus 2 multiplied by x plus 2 and then foiling out, these kind of things can lead you to making mistakes in equations that look this big. So this is a quicker way of doing this. You can just say x squared, square the first one, square the last one and put that at the end. So that was going to be a plus 4. Then to get the middle term, you just say the first term multiplied by the second term. That's 2x. Then take that and multiply it by 2. And that will be 4x. And that's how to simplify that in a quicker way, just so that you can avoid making any mistake. Okay, so we're going to do that with this now. So we have our first term, square the first term. If you square this, that's 2 squared, which is 4, and y squared, which is just y squared. Square the last term. 1 squared is just positive 1. And then to get the middle term, you say the first term, 2y, times the second term, 1. So that is 2y. Then take that 2y and multiply it by 2. And that is going to be a positive 4y. Okay, so that's how we get that. Then we have this over here. You can already start foiling out from here. So negative y multiplied by 2y, that's negative 2y squared. Then negative y times 1, which is negative y. And then, of course, we have the minus 5y minus 3y squared minus 2 is equal to 0. Okay, so here we can start foiling out. That is going to give you 8y squared plus 8y and plus 2. And then over here, already start searching for like terms. So here I see a negative 2y squared and I see a minus 3y squared. So those will go together. Negative 2y squared minus 3y squared is negative 5y squared. So I'm done with those. In a pencil, what you can do is lightly scratch out the ones that you're done with so that you don't confuse yourself. And then we have the y's now. So negative y and minus 5y, and that will give you a negative 6y. So I'm also done with those. Then we just have the negative 2 is equal to 0. And then, of course, still look for more like terms. In this one, we have the 8y squared and minus 5y squared. So that is going to give you a 3y squared. Then we're looking at the y's. We have a positive 8y minus 6y, which is going to give you a positive 2y. And then lastly, as you can see, this is a positive 2 and a negative 2, and those would cancel. 2 minus 2 is 0. So that is gone and then is equal to 0. Okay. So this is where our equation is leading us to. We have y squared plus 2y is equal to 0. Notice that in both terms, we have the common factor of y. So we can take y out as a common factor, and then we're going to have 3y remaining. Remember, just say this divided by the y. So 1y will cancel, and you're left with 3y. Again, positive 2y divided by y, the y's cancel, you're left with positive 2 is equal to 0. Okay, now you have something multiplied by something is equal to 0. So it's either that y is equal to 0 or that 3y plus 2 is equal to 0. So here we have y is equal to 0. Here we're just going to simplify this. So 3y is equal to negative 2. And then divide both sides by 3. Then y is just equal to negative 2 over 3. So these are two solutions for y. And this will account as our equation 4, since we already had 3 equations so far. So first we substituted 3 into 2. Now we're going to substitute 4 into 3. So you see the pattern is quite easy. 3 into 2, 4 into 3. So we're going to substitute equation 4 into 3. So our equation 4 into 3. The equation 3 is this. X is equal to 2y plus 1. So since we have that x is equal to 2, and then in place of that we're going to put y plus 1. So the first equation for equation 4 is where y is equal to 0. So when y is equal to 0, let's find out what x is. So in place of y, we're going to put 0. So x is going to be equal to 2 times 0 is 0 plus 1 is just 1. So where y is equal to 0, x is equal to 1. Then we have or, again, x is equal to 2, and then we're putting in y this time as this negative 2 over 3. So in place, we're putting negative 2 over 3, and we're going to have x is equal to, so negative 2 over 3, we're just seeing this so we're just going to see this like this. This 2, since it needs to multiply to a fraction, let's also make it a fraction. So we can put it over 1. So when you're multiplying fractions, you multiply numerator with numerator, denominator with denominator. So on the top, we're going to have negative 4 over 3 and then plus 1. So you can put this on the calculator, but I would also just do this instead. I'll change the plus 1 so that the denominator is 3. I'll change the plus 1 to a 3 over 3 instead. And so we can have negative 4 plus 3. So that's like saying positive 3 minus 4, which is negative 1. So that's negative 1 over the denominator stays the same. So that's our answer. X is equal to negative a third. So that is our answers for the simultaneous equation. Okay, moving on to the next question. So here 1.3, we are told given this 2 to the power of x plus 1 plus 2 to the power of x is equal to 3 to the power of y plus 2 minus 3 to the power of y, where x and y are integers, determine the value of x and y. Okay, so now that we have this down, first of all, since we have to solve for x and y, the goal here would be to try and simplify things. And when you're trying to simplify things, the first thing we'll be doing here is trying to see what is common throughout. So if you look at this first part, we have 2 to the power of x. I also see 2 to the power of x being repeated here as well. And here we have 3 to the power of y. And you see 3 to the power of y is also being repeated. So what we can do is separate these and make them have their own bases first. So I'm going to rewrite this as we have 2 to the power of x being multiplied by, that plus 1 came from 2 to the power of a positive 1. Remember, if the bases are the same and we are multiplying, you need to add the exponents. That's how we got from this to this. So I'm just separating them so that they can have their own bases. Then we have plus 2 to the power of x. It's just easier to do it this way so that you can easily see the common factor. Is equal to, I'll do the same thing here. So 3 to the power of y being multiplied by 3 to the power of 2. Then minus 3 to the power of y. Okay, so again, remember, these are the common factors. So we're just going to take them out as common factors. So here I'm taking out 2 to the power of x. So 2 to the power of x, open a bracket. In the first one, what do you have to multiply to this to get back to this? So of course you have to multiply by this. It's the same thing as saying this divided by this. So we're left with the 2 to the power of 1, but we don't have to write that one. Then we have a plus 2 to the power of x. So if you said this, positive 2 to the power of x divided by 2 to the power of x, that's just going to give you a positive 1. Because it's like, what must I multiply to this to get back to that? It's the same thing, just multiply by 1. Is equal to, again, take 3 to the power of y out as a common factor. So 3 to the power of y, open up a bracket, and we're going to have, what do we have to multiply to this to get back here? 3 to the power of 2. And then we have the negative 3 to the power of y. So we're going to have this divided by this. And as you can see, they're the same thing. They would cancel and you just be left with minus 1. Okay. Now things are actually looking much more better because we can see numbers now. This is a number here that can be simplified. This can also be simplified. So let's simplify those numbers first. We have first a 2 to the power of x being multiplied by, that becomes 3, is equal to 3 to the power of y. And then 3 to the power of 2 is 9. 9 minus 1 is 8. So multiply by 8. Okay, now that we have it in this form, our bases are being multiplied by each other. So look at the pattern that we have. We have over here, we have a 2, then we have a 3. Then here we have a 3, but here we have a 8. So is there a way that we can make 8 have a base of 2? So 8 can be written as a base of 2 because 8 is equal to 2 to the power of 3. So we can do that. Change 8 into 2 to the power of 3 so that they can have the same bases. Okay. So we're going to say 2 to the power of x multiplied by 3 is equal to 3 to the power of y multiplied by 2 to the power of 3. And now this pattern is going as the base is 2, here the base is also 2, and here the base is 3, and the base is also 3. Remember, these things are being multiplied by each other. So they're saying 2 to the power of x multiplied by 3 is equal to 3 to the power of y, or let me actually put it in the same order. I'll put the 2 first. 2 to the power of 3 multiplied by 3 to the power of y. This, for you to understand this is exactly the same thing as me saying, if 2 to the power of x multiplied by 3 is equal to 2 to the power of 6 multiplied by 3, then what is x? Now in this case, you'll be like, okay, but they all look exactly the same, so x must be 6. And that's exactly what you have to do here. Look at the fact that we have 2 to the power of an x, but over here we have 2 to the power of 3. So it means that because all our bases are the same, we have a base of 2 and 3 and they're being multiplied by each other. It means that x is equal to 3. And here we have 3 to the power of an invisible 1. And here 3 to the power of y. And they're being multiplied, you see. So it means that y is equal to the 1. The only way you would not be able to do this is if this had a plus. So 2 to the power of x plus 3 is equal to 2 to the power of 3 times 3 to the power of y. Then you can't say they're the same. But here they are the same because we are multiplying these two bases, and over here we have the same bases being multiplied. So the exponents are equal. Okay, moving on to the next question. Okay, so 1.4, the equations of x squared plus rx plus m is equal to 0 and x squared plus mx plus r is equal to 0 have real and equal roots. And they put in equal in capital letters, probably to emphasize this in the fact that you're going to have to use this. Solve for the values of r and m if r is greater than 0 and m is greater than 0. So also some restrictions on r and m. Okay, so let's go for this one. Okay, so in this question, because they're saying that these two equations where r and m are both missing in both, they have real and equal, big emphasis on the equal roots. Okay, and we have to solve for r and m if r is greater than 0 and m is greater than 0. Because they're emphasizing about the roots being equal, you have to look at what deals with the nature of roots, whether you have equal roots, whether you have unequal roots. The only thing that deals with the nature of roots is delta. And remember, delta is equal to b squared minus 4ac. So what delta tells you is the type of roots that you're going to get. They specifically want equal roots. So I can lay down the different categories of roots that you can get using delta. So if delta is greater than 0, you're going to get roots that are unequal. They will be real, okay? They will be real, but they'll be unequal. And if delta is less than 0, your roots will just be non-real. Okay, and if delta is equal to 0, you're going to have roots that are both real and equal. And yes, delta is actually that part in the quadratic formula, this part. Okay, so this part over here, and it will tell you the type of roots that you're going to get. The reason it tells you the type of the roots is because of the square root. When you square root a number, it kind of tells you the nature of the number that you have. Okay, so this part over here. So we're going to go ahead and use this. They want where delta is equal to 0 because they specifically asked for real and equal roots. So that's what we're going to do. And remember, they said that for both equations, that both of these equations have real and equal roots. So we're going to just go ahead and work with this one where delta is equal to 0. So remember that delta, and I'm actually going to split this into two parts. So one part for this equation, the other part for the other equation. So let's go ahead and use delta on these two equations. So in the first one, remember delta is just b squared minus 4ac, right? And we're making delta, b squared minus 4ac, equal to 0. Okay, so in this equation, in the red one, our b is going to be, remember the b is just whatever the coefficient of x is. So here's x, the coefficient of x would be positive r. So our b squared, so this is b, our a would be the coefficient of x squared, which in this case would be our invisible positive 1. And our c is just the only term without x in it. So we have positive m. So this is a, this is c. So let's go ahead and substitute these into here. So we're going to have our r, and that is going to be squared, and then minus 4, and our a is just 1, so minus 4 bracket 1 bracket our c, which is m, is equal to 0 because our delta needs to be equal to 0. Okay, so let's see what we get when we simplify this. This is going to be r squared. Negative 4 times 1 is just negative 4. Then times m is negative 4. M is equal to 0. Okay, at this point, I usually just stop and then work on the other one and just see how the equations are going to look, which one is better to make something a subject in, and so on. So I'm going to jump over to the blue one, and I'm also going to use delta on this. I will not repeat this because I already know what delta is. So let's go ahead and we know that our a here is going to be our invisible 1. Our b is the m, and our c in this case is r, the only thing without x. So putting delta into this, we're saying the m squared, so m all squared, then we have minus 4, and then a is 1, and of course c is just the r, and delta needs to be equal to 0. So here we just have m squared minus 4r is equal to 0. Okay, so in both equations we have a square, but we're basically just trying to solve for r and m in both equations. So what we can do here is make one of it a subject. You can choose here, you can choose to make m the subject, so take 4m over, or you could make r the subject here and take that over. But let's just say we use this one. So we have r squared is equal to, and I'm taking this negative 4m over. Now I have positive 4m. And then to make m the subject, we're going to have to divide both sides by 4. And then we have m is equal to, so that's m is equal to r squared over 4. Okay, so now that this has been done here, you don't really have to make this one a subject. What we can do is just call this our equation 1, and then that can be our equation 2. So in order to solve for something, we can just go ahead and substitute equation 1 into equation 2. So substituting equation 1 into equation 2. So wherever you see m, replace it with r squared over 4. So here we have m squared. So I'm going to replace that with the r squared over 4. And so that is squared all squared minus 4r is equal to 0. Okay, so let's focus on this part now. So we have r squared being squared. That's going to become r to the power of 4 over 4 being squared. So we're squaring the numerator and denominator, which will become 4 squared is just 16. So we have minus 4r is equal to 0. So here you see that we have to solve for r. Now, personally, I don't like the 16 being here on the denominator. So I'm going to get it out of the denominator by multiplying both sides of the equation by 16. And so now we have that 16 and this 16 would cancel. And so we have r to the power of 4. And then 16 multiplied by negative 4r, that's going to give you a negative 64r is equal to 0. Okay, so still solving for r. Notice that in the first and the second term, r is common in both. So we can take r out as a common factor and open a bracket, and now we have r to the power of 3 left here. Because if you divide those, you're going to get r to the power 3. Then negative 64r divided by r, the r's will cancel, you're left with negative 64 is equal to 0. Okay, and now we can go ahead and just equate them both to 0 because they're being multiplied. So I'm saying that either r is equal to 0 or r to the power of 3 minus 64 is equal to 0. So here r is equal to 0. Here we have to solve for r. So in this is difference of two cubes, not difference of two squares. And this is something that I know is actually done in grade 9 and it's easy to forget in grade 12. But this is why you need to revise on every single method of factorizing: difference of two squares, difference of two cubes, sum of two cubes. So this is how we would factorize this. So there's actually two ways of factorizing this, but the other way is not going to find your other solutions. So since this is difference of two cubes, you could have done this. Open up a small bracket and then a bigger bracket, set it equal to 0. Then you say the cube root of r cubed, which is r, and the cube root of negative 64, which is going to be your negative 4. And then to get the other bracket, you're just going to say this r, square it. That's going to be r squared. And then your negative 4, also square that. That's going to be positive 16. Okay, then you're going to say r multiplied by negative 4, which is negative 4r. Then change the sign to a positive. So that's positive 4r. Okay, so this is another way. So in this case, we're either saying that r minus 4 is equal to 0, or this r squared plus 4r plus 16 is equal to 0. So here r is either equal to 4 or this. Now in this, as you can see, this cannot be factorized because it's all positive first of all, and this is 16. There's no way you can get two factors of 16 that can give you a 4 in the middle. 16 is too big. So this is one of those ones that's going to have to use the quadratic formula. But you actually don't need to do this. The reason why is, if you look at the restrictions they gave you, they said that r needs to be greater than 0. So think about your answers here. The answers that you're going to get here, because everything here is positive, when you have your factors down, I know you cannot actually put them as physical factors because you have to use the quadratic formula to factorize. But even if they could have been put as physical factors, because everything is positive, you must have had a positive and a positive. These type of factors, no matter what they are, when you are simplifying or solving for x, you're going to have to say r plus whatever you had is equal to 0. Then take that thing over and it would have become negative. So r would have been equal to a negative number. So either way, these ones will not even be considered. So I wouldn't even take them from here. From here already, I'm already going to leave those because they said. So I'll just say, but r is greater than 0. And so from here, I'm only going to accept answers greater than 0. Meaning I cannot accept this answer equal to 0. I cannot accept this answer because they will give me negative values. I can only accept this one. So there's actually a quicker way to solve for this r cubed minus 64. So if you took r cubed minus 64 was equal to 0 and you took the negative 64 over, you would have r cubed is equal to 64. If you cube root both sides, you will have r is equal to 4. So this will only give you the real solutions. It will not give you this one. The thing about this one is, even if you use the quadratic formula on this, it would have told you error because this part would give you your non-real solutions. So you don't actually have to get into that. They only ask for where r was greater than 0. So we can just take this one. So since we have this now, we had our equation 1 and 2. This will be our equation 3. So we found r. So since we have now our equation 3, we can go ahead and substitute it so that we can find m. So which equation had m as a subject? You see, equation 1 had m as a subject. So we can substitute 3 into 1. So putting 3 into 1, m is now equal to, r is 4. So 4 squared over 4. And so m is equal to 4 squared gives you 16. 16 divided by 4 is just 4. So m and r have the same value. Okay, so that's how to find m and r, by using the fact that they told you that the roots were real and equal. So you have to use delta. Okay, so that concludes it for question 1. So moving on to question 2, we have given the quadratic sequence and we've been given this. So we first have to determine an expression for the n term of the pattern in the form of tn is equal to an squared plus bn plus c. Okay, so finding the formula of this. So it's 4 marks. So this is really places that you can't score marks. So we're going to first of all find the first differences. So we can go ahead and just say 14 minus 10. That's going to give you 4. Then 10 minus 12, that's going to give you a negative 2. And then 12 minus 20, which is negative 8. Okay, so that's our first difference. Then we have to find the second difference, and we'll just say 4 minus negative 2. So it's like saying 4 minus negative 2. So that will become a plus. So it's 4 plus 2, which is 6. And then negative 2 minus negative 8. It's like saying negative 2 plus 8. And you can rewrite this as 8 minus 2, which is 6. Okay, so we have our first difference and our second constant difference. Then we take the first terms in each of these patterns, the quadratic first difference and second difference, and we're going to equate it to the following. So the second difference, we make that equal to 2a. Then first difference, we make that equal to 3a plus b. And then this one, it's a plus b plus c. Okay, so if 2a is equal to 6, then just divide both sides by 2. And so a is equal to 3. Then we have to find b now. So 3a, but I know what a is, it's 3. So 3 bracket 3 plus b is equal to negative 8. And so 3 times 3 is 9. And we have b is equal to negative 8. Since this becomes 9, take it over and becomes a negative 9. B is equal to negative 8 minus 9. Negative 8 minus 8 is negative 16. So negative 17. And then, so we have B. And now we have to find C. So A is 3. Then we have B, which is, so plus B. But since this is negative 17, you can just say minus 17. Plus C is equal to 20. Okay. So I'm going to just say C is equal to 20 and figure out what this is. 3 minus 17 is negative 14. If you take it over, it becomes positive 14. So C is equal to 34. Okay, so we have A, B, and C, and so it means that Tn is equal to 3n squared minus 17n plus 34. Okay, and that is 4 marks. Moving on to the next question. So the next question says, the first differences form an arithmetic sequence, okay, like it always does. Determine between which successive terms, so successive, they come after each other. In the quadratic sequence, the first difference will be 148. Okay, let's take on that question. Okay, so in this question, let's look at the pattern so that this can just make more sense. Okay, so let's try to understand what the question exactly, what are they asking for? So they're saying the first difference of an arithmetic sequence, the first differences, form an arithmetic sequence. So this is our arithmetic sequence. And they ask us to determine between which two successive or terms that come after each other, which two terms that come after each other in the quadratic sequence will there be a first difference, okay, of 148. So in this arithmetic pattern, where do we want to find out between which two terms in the quadratic pattern will you have a first difference of 148. Okay, so to understand this, first find out which term exactly in the arithmetic pattern is equal to 148. And when we find that, we'll be able to figure out between which two terms in the quadratic pattern this is speaking about. So to find out which term in this arithmetic pattern will have the value of 148, we need to find the Tn formula of this. Okay, so actually we don't really need to find the Tn formula, we just need the general formula of it, which is Tn is equal to A plus n minus 1 times D. So Tn is equal to, our first term is the negative 8 plus n minus 1, and our D, our constant difference, is the 6. So we have to find out which term belongs to this 148, first of all, in the arithmetic pattern. So to find out that, in place of Tn, we're going to put 148 is equal to negative 8 plus the n minus 1 and then times 6. Okay. And so here, what we can do is just take the negative 8 over instead. So we have 148 plus 8. So 148 plus 8, that will give you 156. 156 is equal to, and now because these two have been multiplied, I'm just going to put the 6 in front, then n minus 1. Okay, we want to find n, so we can just get rid of the 6 by dividing both sides of the equation by 6. Okay, so what is this 156 divided by 6? It's 26. So that gives us 26 is equal to n minus 1. And if you take the negative 1 over, you get 27 being equal to n. So it means in the arithmetic pattern, this is the 27th term. This is T27. This is not the question. The question is between which two terms in the quadratic pattern would this belong to? So if we know in the arithmetic pattern is the 27th term, then to find out which two terms in the quadratic pattern, you could think about it in this direction. So T2 in the arithmetic pattern, which is equal to negative 2, is found between these two terms in the quadratic pattern. And these two terms, as you can see, this is the second and the third term in the quadratic pattern. So if this is T2 and T3, and another example of this, we can also just look at this one over here. This is term 3 of the arithmetic pattern, and it is found between term 3 of the quadratic pattern and term 4 of the quadratic pattern. So it means that term 27 must be found between term 27 of the quadratic pattern and term 28 of the quadratic pattern. So that's what they're just doing there. So that is your answer. You need to answer them in terms of the quadratic pattern. See? So the successive terms in the quadratic sequence. So our final answer, we have to tell them this is in term, or this will be found between, depending on how they ask, between which two successive. So you can say between term 27 and term 28. Moving on to the next question. Okay, so the next question, 2.1.3. Determine the smallest value of n for which Sn is greater than 10,140 in the arithmetic sequence. Okay, so in that first difference of this pattern. So we're only using the arithmetic sequence in this case. So this part, -8, -2, and 4. So I'm going to put that down. We have -8, -2, and 4. This is our arithmetic sequence. Now we have to find this Sn of this, the sum of the terms. And when we're trying to find the sum of the terms, just focus on the things that you would need. When we're speaking about sum of terms in an arithmetic pattern, there's two formulas you can use. You can either use this first one. Now, in this one, you need to know that last term. Or you could use this second formula. So, deciding which one we should use is based on what we have. So, because we don't know what the last term is, we have to use this one. So we have to find out where the sum of these terms are greater than 10,140. So in place of Sn, I'm just going to put this formula. Okay, so now that we have this, and we have to say that this is greater than this 10,140. So since we have this formula, you can see the things we need. We obviously cannot find n right now. We need to solve for n for this inequality. But we have to have a and we have to have d. So let's see what a is. A is the first term, which is 8. So we can see that. And d, remember we knew what d was already. It's the constant difference, which is 6. So we can go ahead and just fill in. So we just have n over 2 and then 2a. So 2 brackets, we're going to put in -8 as our a. And then we're going to have plus the n minus 1, again, we don't know n. And then in place of d, that is 6. Okay, and that needs to be greater than 10,140. Okay, so this is just algebra, just solving this part so that we can get to our final answer. So with this inequality, we can start with this bracket. Multiply these first. So we're going to have the n over 2 and then open a bracket. This is going to become a -16. Then this, I'm going to multiply it like this. The 6 is multiplying to the n, and the 6 is also multiplying to the -1. So we have a plus 6n and then a -6 being greater than 10,140. And then we have n over 2. And then, of course, I'm just going to write the 6n first since it's positive. This one, -16 minus 6, is going to give us -22. So -22 being greater than 10,140. Okay, then I can just multiply these into here. So I'm multiplying this into this. To multiply it easily, make this a fraction by putting it over 1. So it's just the numerator times the numerator, which would be 6n squared, denominator times denominator over 2. Then again, this multiplied by the -22, numerator times numerator, -22n over denominator. And then we can also put a denominator here over 1 because it's a whole number, then over 2. Then that is greater than 10,140. Okay, then 6n squared divided by 2, that's just going to give you a 3n squared. Then we have negative 22n divided by 2, which is negative 11n. And then we can take this over, so bringing it as negative 10,140 being greater than 0. Okay, now at this point, I will just use the quadratic formula here. So I'm going to substitute this into the quadratic formula as a, b, and c. And as you can see, when I substitute it into the formula, the quadratic formula, when I'm putting a minus first for n, right? I'm not saying n is equal to this because this is an inequality. But the first value I get is negative 169 over 3, which is definitely not your answer because it's already negative. So we cannot get that as the answer. So you can just focus on the second one. If you change that to a positive, we get 60. So n and 60. So I'm not saying n is equal to 60. We still have to solve for this. So we got our critical values, and since this is a quadratic expression or inequality, it's going to form a parabola. But you just have to remember what type of parabola it's going to form. Is it going to be concave up or down? Because n squared, okay, the coefficient of n squared is positive, it's going to be a concave up parabola. So it's going to just concave up like that. Then remember, you just need an x-axis. You don't necessarily need a y-axis. I only put a y-axis in the previous one just to explain the concept. Remember, every part of the graph that is above the x-axis, this being the x-axis, those are the parts of the graph that have y values greater than 0. And then below has y values less than 0. But remember, okay, now we have to put our x-intercept here. Here, as the first x-intercept is a negative 169 over 3, but I'm not even going to focus on that. And then the 60, I'm going to focus on that because it's a positive value. So remember, we just want the parts of the graph that is greater, okay, than 0. The y values must be greater than 0. And that would be, since I'm only concentrating on the 60, I cannot take anything below here. Those are y values smaller than 0. I have to take all of that. So now line these values down to the x-axis so that you can see their relation with this number 60. So these are the values that you have. You see, these are values that are greater than 60. They're moving towards that direction. So here we are saying n is greater than 60. So I'm only focusing on that 60. I'm saying therefore n is greater than 60. But now let's go back to the question and just make sure we are answering the questions. So they said, determine the smallest value of n, okay, for which this is greater than that. Okay, so the fact that they're asking for the smallest value of n, this is what they're actually saying. And this is how you can understand these types of questions that they always put in. Okay, so focus on your solution. Your solution is saying that n is greater than 60. Remember, these are patterns, so we are taking things like the first term, the second term, not really the 5.2 term. So we're going to be looking at integer values or whole numbers. But for this solution, since they said n needs to be greater than 60, let's think about n values. Let's think about answers that are greater than 60. So our solution, or the things that would work for this inequality, is things like this, where n is, it has to be greater than 60. So where n is 61, where n is equal to 62, where n is equal to 63. Remember, I'm only showing you this so that you can understand what they mean by the smallest value of n. So if they want, what is the smallest value of n? Looking at all these solutions and all the things that n can also be equal to 64. These values will help you to make this expression, this over here, to be greater than 10,140. So these are all values of n. These are all the right answers for n. But remember, they want specifically the smallest value. So if this answers had to continue, which one will be the smallest value of n that will make that expression to be greater than that 10,140? The smallest solution of n that you have would be this one, where n is equal to 61. So that's how you can think about it. We're looking at all the values of n, all our answers, and we want the smallest answer. So therefore, because they ask for the smallest value, they're not asking for an inequality, a range of answers. They're asking for one specific answer, n is equal to 61. Okay, so that is 2.1.3 done. We're moving on to the next question. So our next question, 2.2, if we have the sum of r plus b is equal to 10a, so they're already telling us what that sum is equal to, starting where r is equal to 1 and ending where r is equal to 5, we have to determine b in terms of a. Okay, so let's go ahead and find this. First of all, since it's speaking about sigma or the sum, we're going to have to use the sum formula, but we have to know what type of pattern is this. Because you have r plus b, it's already arithmetic. No guessing about that. So we can either have it as arithmetic or geometric, but we can see here in this case, it is arithmetic, except for in those other special cases where they give you some formulas where the patterns just really repeat themselves. It's just the same thing over and over. Okay, but in this one, it's clear that this is an arithmetic pattern. So we're going to be using the arithmetic formula. Remember, there are two formulas you can use. You can either use this one or you can use this one. But for this one, I would rather use this because it's easier. And in this case, we have L. We can find L. We may not have it, but we can actually find it. So let's go ahead and focus on the things we need to find since we know we are using this formula. If you're using this formula, you're going to have to find the following. First, you're going to have to find n, of course, so knowing how many terms they are, but n will be very easy to find. So we're saying n is equal to, the number of terms is equal to, you always say the top number minus the bottom number and then plus 1. Okay, you only say this because sometimes r may start, or the starting point may not be at 1. Okay, so you need to count each and every term. So in this case, it's just 5 minus 1 plus 1. And so that will cancel, and it's just equal to 5 terms. Then we have a, so we have to find a. To find the first term, just substitute that r is equal to 1. That will give you the first term. So a would be equal to, we're going to say the r plus b, but in place of r, we're going to put 1. So as our first term plus b. So this is our a. And then we have to find in this formula, the things we have to find lastly is L. So L is the last term. They told us where this pattern or the series is going to end. It's going to end where n is equal to, or r is equal to 5. So in place of r, we're going to put 5. So L would be equal to the 5 plus b. Okay, so we have everything that we need now in this. We have our n, we have our a, and our L. So let's just put this in the formula, and we know what Sn, the sum of these amount of terms, these 5 terms, it's going to be equal to your 10a. Okay, so we're saying that Sn is equal to, I'm actually just going to copy from here. So we're just using this. So S of how many terms? We have S of 5 terms. S of 5 is equal to, n is 5 over 2, and then a is this, 1 plus b. So 1 plus b plus L is 5 plus b. Because it's a plus, you don't need any brackets. So 5 plus b. And then we know that S5 is actually, or the sum of the terms. They told us here that the sum of these amount of terms gives you 10a. So we replace 10a over here. So 10a is equal to, we still have the 5, sorry, I said 1a. 10a is equal to 5 over 2. And then let's add these. So we have b plus b, which is 2b, and then 1 plus 5, which is positive 6. Also, just remember, they said you need to determine b in terms of a. So it needs to read as b is equal to something something, and a needs to be part of your answer. So that's all we're going to do. Try to make b the subject, and naturally a will just be part of what it's equal to. So let's go ahead and make b the subject. Okay, so to make b the subject, I'm actually just going to try and get rid of this. It's easier to get rid of that first. So we can go ahead and just divide both sides of the equation by 5 over 2, 5 over 2, and then we're going to get this. So this is 10. I know it's 10a, but 10a divided by 5 over 2. So 10 divided by 5 over 2. And that gives you 4. So 4 is equal to, and then these will just cancel. And then you're left with the 2b plus, 4a. I forgot about the a, plus 6. And now we just have to make b the subject. Okay, so take 6 over. We have 4a minus 6 is equal to 2b. And then divide both sides by 2. And so we can therefore say that b is equal to 4a divided by 2. That's 2a. Negative 6 divided by 2. That's minus 3. And there we go. That's our answer. We have made b the subject, determined b in terms of a. Okay, next question. Okay, so that is it for question 2. Then we're going to move on to question 3. So now we're on question 3, and this is what we have been given. They say given the following geometric sequence, and we have 24 over x plus 12 plus 6x plus 3x squared plus, and it keeps on going. It's actually a series, by the way. 3.1 says calculate the sum to infinity of the series. So to find the sum to infinity, the formula of sum to infinity is basically a over 1 minus r. So just looking at the formula, we can already see the things that we will need for this. We can see that a is missing, so we're going to need a. We're also going to need r. So you just have to find a and r. Okay, so a is quite simple. A is always just the first term in the series, which is the 24 over x. So we know that a is 24 over the x. And then r, to find r, you can basically just say the second term divided by the first term, or you could say the third term divided by the second term. And that's what I'm going to do because that looks much more simpler than working with fractions like that. So I'm saying the second term, 6x divided by 12. So 6x divided by 12, and this is what we have. Then we just have to simplify this. 6 and 12 have 6 in common. So 6 will cancel on top. 6 will cancel on the bottom, and on the bottom you'll be left with a 2. So our r is really just, we have the x on the top over the 2 on the denominator. So we have a as that and r as that. So let's find the sum to infinity. The sum to infinity is equal to a, which is 24 over x, over 1 minus our r, which is x over 2. So immediately you have it like this. It won't be so nice to work with it like this. What you can do is just split it up by writing this. We're just going to write that 24 over x. And instead of using that, we're going to just use the division. So divided by this 1 minus x over 2. Okay, so let's sort this part out. So we still have the 24 over x being divided by the 1. Since we have to subtract it by this, when you have to subtract or add, your denominators need to be the same. So I can just call the 1 2 over 2 instead. That will still be 1, but the denominator is now the same as that. Minus x over 2. And then we have the 24 over x, and then divided by, I don't need the brackets anymore. I'm going to keep the denominator the same, and the numerator is now 2 minus x. Okay, so when you're dividing, there's a rule called tip and times where you tip the second number and you change the division to a times, to a multiplication sign. So I'm going to do that. That's 24 over x, and then that becomes multiplied by, and this now tips over. Now we have a 2 over 2 minus x. And then we're going to multiply the numerators and the denominators. So 24 times 2, that is 48, over, and we have the x being multiplied by 2 minus x. So finally, the sum to infinity, we just have the 48 over, the x is going to multiply. So we have that multiplying and we get 2x, and that multiplying and we get negative x squared. Okay, so that's our sum to infinity. The series itself had x's in it. So of course, your sum to infinity will also be in terms of x. Okay, moving on to the next question. The next question says 3.2, write down the values of x for which the series converges. I keep saying series because it's not a sequence. Series converges. Okay, so for the series to converge. Okay, so the values for which the series converges. So we know that if a series has to converge, it's going to converge as long as r is greater than -1 but smaller than 1. And really, this just means that when a series or geometric series converges, it really just moves closer and closer to a specific value. When you look at the terms that come after, you will notice that these terms are getting closer and closer to a specific value. And in the case of a geometric series, the terms will basically move closer and closer to the number 0. You're going to start noticing that about these terms. Okay, but this is all we need to know to be able to answer this question. Okay, so what is the value of r that we had? If you scroll up, remember we had this as r, x over 2. So I'm just going to put that in here. I'm saying now that x over 2 needs to just be greater than -1, but smaller than 1. And this is an inequality, we just have to solve for x. Since we have to solve for x, we have to get rid of what is disturbing us from solving for x. And in this case, is this divided by 2. So to get rid of a divided by 2, you're going to have to multiply by 2. But because this is an inequality that has two sides, we're going to multiply by 2 on both sides. So we're saying times 2 and times 2. So we're multiplying by 2 on both sides, and that will get rid of this 2 now. So we just have in the middle an x in the middle. Then we have that x is greater than 2 times -1, which is -2, but less than 1 times 2, which is 2. So that's our answer. This would be the values for which this series, this geometric series, will converge, meaning each term, we're looking at the terms, these terms that follow, all of these terms are going to be getting, so the next term is going to be closer to the number 0. Next term will even get even closer to the number 0, and it's going to keep on happening like that. Okay, so let's move on to the next question now. The next question, 3.3, for which values of x will the series increase? Okay, so for this question, most of the time in maths, and you will notice this throughout maths, the previous question usually has a lot to do with the next question. So notice that when that pattern converges, it's going to get closer and closer to 0. When a pattern is getting closer and closer to 0, it doesn't necessarily mean that it's decreasing. And the reason I'm saying so is because we could have the number 0 here, and let's just look at a pattern. It's not going to be geometric, but I'm just showing you a pattern. A pattern moving closer and closer to 0 doesn't necessarily mean that it's decreasing, because you could have situation like this. Let's say you had -4, -3, -2, this is moving towards 0, but it's increasing. Okay, so that's what I just meant by that. Now, to answer this question, for which values will it increase? You're going to have to look at this. You're going to have to look at these parameters for which it's going to converge and see what is this actually doing to the pattern. So this is the pattern. Let me actually just write down the pattern that we have. So this is the pattern that we have. These are the values for which it's going to converge. Notice that we have where x is greater than -2, right? So let's look for values greater than -2 but smaller than 2. So in this, I don't want to use a lot of numbers. Remember, I'm only doing this just so that it can make sense and you understand what was actually going on here. So for something greater than -2, we can try -1, right? And for something smaller than 2, let's try 1. So I just want to show you what's going to happen, because when x is negative, you're going to see it's going to do something to the pattern, and you're going to just notice how this pattern acts. So let's substitute -1 into this and see what we get. So I'm going to just substitute -1. You can also do that on your calculator, and I'm going to show you what we have here. So I've substituted -1, and these are now the answers that I get from this. So if you look at the values that you get, you will notice these numbers: -24, +12, -6, +3. They are alternating between negative and positive numbers. So when I look at this pattern, I can't really say it's increasing or decreasing. It's neither increasing nor decreasing. And that's of course because of the negative. Now, see what happens when we try 1 instead. So the reason I'm trying to let you see why we're going to focus on this part. So when I substitute 1, you see what this pattern is now doing. This pattern is getting smaller and smaller. It's decreasing. Okay. So you see now that if this case, when x is smaller than 2, then the pattern starts to decrease. So if you think about how will x increase if x decreased for where x was smaller than 2. Okay, I'm not considering negatives because the negatives make it just alternate. When x was smaller than 2, it made it decrease. So it means that to make it increase, you just need to make x greater than 2. Okay, so if you put this answer, you probably still get it right. Another way of looking at this was through the ratio, the constant ratio. We know that when a geometric, specifically a geometric series, converges, what it does is that it moves closer and closer to 0. And so in this case, we will also consider this one, the one where when r is smaller than 1, that pattern is actually going to start decreasing. And so to make this particular series increase, you just basically have to make r to instead be greater than 1. And then of course substitute the value of r, which was x over 2, and make that greater than 1. Then to solve for x, you would have to get rid of this 2 by multiplying both hand sides by 2. And so that will give you that x needs to be greater than 2. You can therefore say that it's going to increase when x is greater than 2. And of course, this is because you saw that it was decreasing for where x was less than 2. Okay, so that is question 3.3, and then we're moving on now to 3.4. And now we have 3.4. If x is equal to 4, determine the sum of the sequence to 15 terms. Okay, so this is just determine the sum of the sequence to 15 terms. So as you can see now, because they're saying that in the previous question, x is now greater than 2, and of course 4 is greater than 2. Notice now that this series does not converge anymore. It's now diverging. Okay, but to find the sum to 15 terms, we're just basically going to have to use the sum formula. So now when using the sum formula, you know that in the sum formula, you need to know what n is, the number of terms, and they already told us that was 15. We also need to know what a is, so we're just going to take our a and substitute 4 back into that. So the value of a before was the 24 over x. That was the first term that we had. So we can go ahead and just put that 24 over, but instead of x, we're going to put 24 over 4 because we know what x is now. So 24 divided by 4, a is just going to be equal to 6. And then lastly, to find the sum, we need the ratio, we need r. So r is going to be equal to, let's just find out what the ratio was before. The ratio was x over 2, and we know what x is now. So since the ratio was x over 2, and we know x is 4, this is just 4 over 2, which is equal to 2. So we know what our ratio is. Okay, so our ratio is 2, and there's a formula that you use when r is greater than 1. So I'm going to use the formula Sn is equal to a bracket r to the power of n minus 1 over r minus 1. And so S of 15 is equal to a, which is 6, open bracket, we have now our r, which is the 2. So I'm just going to say 2 to the power of 15 minus 1 over 2 minus 1. And then you can go ahead and just put that onto the calculator and see what you get. And so when we substitute that, we get 196,602. So that is the final answer. Okay, and that's it for 3.4. And that is it also for question 3. So now moving on to question 4.